So thank you for your time today. My name is Sundar Ranganathan, Senior Product Manager for AI at NetApp, and we have two parts to this short presentation. I'm going to go over the data part of AI, and then Vinod is going to go over a live demo. So let's get started. We have a lot of ground to cover. Machine learning is a subset of AI. Deep learning is a subset of machine learning. And the reason why we're talking about AI and it's taken a center stage in the industry today is because of three big things. Firstly, you have massive amounts of data that's usable right now. Second, the emergence of GPUs and parallel compute engines. And thirdly, we have software tools and frameworks. So let's go into a little bit of detail here. So this is a typical deep learning model framework, and this is how the flow is. So everything starts really with what the application is. Once you figure out what your application is, you're going to choose what the framework is going to, which framework you're going to be using. And usually the frameworks are very important because it simplifies model building. It allows you to connect layers and allows back propagation as well. So once you have the raw data set, this is where you have to pre-process the data, because you have to enrich the data and clean up, transform the data, label, for example, add metadata to it, and only then you can start using, because your AI algorithms and prediction percentages are a direct aspect of how good your data is. So once you have your data figured out, you're going to pick which neural network you're going to go with, and again, this is going to depend on what's your application going back. So convoluted neural networks for image recognition or object detection, ResNet 50, 152, VGG16, Inception V3 are very good examples here. Recurrent neural networks usually works very well with time series data, and where the result actually depends on the past data points. And LSTM is a very good example here. And going over, one more example of this would be reinforced learning, where the answer really depends on a history of moves. So a game like chess or Go would fit into this class. So once you have this figured out, you're going to be preparing your environment, and we're going to be talking about this in detail. You can download your containers from, say, NGC, for example, NVIDIA GPU Cloud. You can come up with Python scripts, use framework APIs, automate many of the tasks in the pipeline, like reading the data, feeding the data into the training clusters, for example, and launching the training runs themselves. Once you have the training runs completed, you're really talking about, what do you do with the trained model? You push it for inferencing in the machine learning world. So the top part almost remains the same, except that the frameworks and tools may be a little different. You can have H2O, for example, fits very well here. Rapids, recently announced by NVIDIA, fits in here as well. And once you have your data cleaned and cleansed, you have to choose your algorithm. And again, this goes back to what your application really is. SVM for image classification kind of applications, random forest for ensemble learning, k-means for clustering, and you have deep learning as well included, because deep learning is a subset of machine learning. And you prepare your environment again here. Again, the bottom part is very similar to what we saw in the previous slide. But the key takeaway over here is the blue row on the top is really read-write heavy workloads. And you want to make sure that you want to complete this as soon as possible, because this is the most time-consuming time of the entire flow. And the bottom part, which is in green, is really parallel compute intensive. And this is where the GPUs come into the picture, and inferencing is another big area of focus when you're really wanting to expose your trained models to new sets of data. Let's back up and understand what does all this mean in a high level, deployment considerations when you're talking about scale out deployments. So few considerations over here to keep in mind is, where do you have to deploy? Where do you want to deploy? Is it cloud? Do you have an on-premise data center? Or do you have a hybrid kind of environment where you have an on-premise footprint with a cloud connected environment over there? What kind of frameworks we're going to use? This is where we know this is going to come and run a live demo for us. And how is the important part about data management, and this is where NetApp really comes into the focus. How do you wrangle your data? How do you manage your data end to end? And how do you orchestrate training and inference? So talking about data, right? So data is key, but also the problem. So this was a survey that was done by an independent research firm, and the top 4 or 5 problems are really data related. So let's just break it down and summarize it. So data in silos. So you have multiple departments working on different sets of data. The question is, how do you unify all of this data and bring it to one location? How do you move this data? Too many technologies running on the same data set. So you have Spark clusters running CPU-based architectures, for example, and you have artificial intelligence or deep learning running GPU-based technology. How do you orchestrate the movement of data between these two? Or how do you orchestrate using the same data set or data lake to feed into these two different type of computer architectures? Accessing large amounts of data very quickly. So this is again very important because we want to move the data from the network into the GPU clusters as soon as possible. So recognizing all of this, we came up with a reference architecture along with NVIDIA called NetApp.ai, which really addresses all of the above, all the challenges we saw on the prior slide. It's really fast. You can move your data as quickly as possible from the network into the GPU clusters to maintain a very high percentage of utilization. Your scalability, right? You can start small and really scale big, independently scale compute and storage. It's very simple to deploy through Ansible automation scripts. And integrated data pipeline is how do you move the data from the data sources into the clusters, and how do you move it out of the training clusters and push it to deployments? How do you leverage the cloud to do, say, cold data tiering, automated policy-based cold data tiering? This was based on recent experiments. What we did was we used for deep learning, we used ImageNet as the data set, and this includes about 1.5 million images. Two big things, right? So we were able to derive the maximum throughput in terms of images per second, and we were able to achieve linear scalability when you increase the number of GPUs from 8 to 56. And on the machine learning side, we recently worked with NVIDIA at Rapids. This was a text-based mortgage data set that we used, and we got performance results very close to what you would get if all the data was actually sitting was being accessed by the RAM in the system itself. And this used XGBoost. So the true power of NetApp.ai comes when you're talking about end-to-end data management, and we have solutions that has you covered across the board, right? From the edge to core to cloud. So we have for data collection, we have solutions at the edge. To move the data, we have Cloud Sync that securely moves your data from the data source from the edge, for example, into the core or to the cloud directly. And for the cloud part, we have Fabric Pool, which is an automated policy-based cold data tiering solution, which you can leverage the cloud for. And what if you don't have an on-premise data center? What if you're completely resident on the cloud? We have Cloud Volumes Service that we're very happy to talk about, and most of our integration with Driverless.ai uses Cloud Volumes Service. So let's see what that is. So Cloud Volumes Service is our cloud-native file services, on AWS, Azure, and GCP. It supports NFS, V3, V4 is coming up very shortly, and also SMB file services. You can scale from 0 to 100 terabytes in a matter of seconds, and it's a pay-as-you-go model. So it comes with data protection, cloning, and replication as well. So we use this Cloud Volume Service for AI, and these are the key takeaways, right? In terms of GPUs, we were able to maintain the GPUs at 95% utilization. We were able to scale very easily, and I'm very happy to announce that we integrated with Driverless.ai as well, and we'll go over a live demo with my colleague here, Vinod. Over to you.
Thank you, Sundar. So this is pretty cool, right? So for folks who saw Driverless.ai earlier, what we have essentially achieved. So this is a slide most of you probably seen many places, but the typical data integration, data science workflow, data coming in from different silos, bringing it all together. Then you perform data quality and transformation. This is where data preps techniques come in. Once that's done, you run through feature engineering, model building, and this is an iterative process to get the final model. Now, in the H2O environment, H2O and driverless paradigm, how this fits in is basically this. So you have train and test and validation data sets and other data sets you want to bring in. You could be running this either on-prem or cloud. And then once you build a model, you want to deploy it to do real-time scoring or batch scoring. And then the model artifacts themselves can be deployed. Now, how we can fit this in with NetApp is by bringing in a common storage layer for the entire workflow. So be it pulling your data from an on-prem data source or cloud or hybrid for that matter. You can have one common storage volume, and this is what we're going to demonstrate with Cloud Volume, one common storage layer for bringing all your data and storing all your models as well. And what this means in practice is a few things. So I'm going to switch over to the demo. Okay. So this is the NetApp Cloud Volumes interface. So when you come in, what we did is I have one Cloud Volume instance up, basically a terabyte drive, which is mounted. And I have multiple Driverless.ai instances now accessing that. So this is an instance I have up and running. So what this means is, and this is a second instance I also have. So you can see they're both running on EC2, they're both mounted. So in practice, what it looks like is, I'm going to go to the file system, I'm going to go to home, Ubuntu, and here you see the H2O NetApp demo. That's the same Cloud Volume that I'm mounting. Once it's in there, it looks just like a local file system. I can pull any data set from here, and let's pick this one data set I don't have, alt state. Okay, I'm going to import this file, and once I do this, it's going to treat it just like a local disk. And the benefit of doing that is, as this data set gets pulled in on this instance, I can go to this second instance, and boom, I see the same data set. So if I have a team of data scientists all working together on individual Driverless.ai instances, all we need to do is put a data set in there once. Once I import it, all my team members have access to it. So that's the first benefit. And it's more about convenience. I mean, yes, you can achieve that using other tools, but this is about convenience, how easy it is, and the speed of doing this, right? The second thing I'm going to demonstrate is I'm going to start an experiment. And actually, I have one running. In the interest of time, since you only have 10 minutes for the demo, I took this Rosman dataset, it's a Kaggle competition, time series problem, and I have this running on a cheap CPU instance. So it's not a very high powered instance. So it's doing time series on a smallish dataset, and you can see that it's consuming the CPUs, it's firing up, and it's gotten about halfway. And I realized, you know what? I wish I had done this on a GPU instance and take advantage of all the work I've done already, so I don't have to restart, but I can do this a little faster. So that's exactly what I'm going to do. I'm going to finish this and then go to the second instance. I can look at, and because they're all being mounted from the same temp folder, I can see the experiment. So I can see that the experiment is stopping. I'm going to take this one, and this is one of the new capabilities we introduced in Driverless.ai recently, is the ability to checkpoint. So what that means is I can restart from the last checkpoint. So it loaded up the data set, the exact same settings. And all I'm going to do is, in this case, I'm going to enable the GPUs, meaning I'm going to take advantage of the GPUs that are available in this instance to restart the same experiment. And even though it's going to show starting from 0, what it's going to do is it's going to take advantage of all the work that's been done. So the feature engineering workload that was done previously, the model building that was done, so it's going to speed up that process much more significantly. And the benefit of running on GPUs is that this is a 2 GPU instance in this case, the entire workload will be much faster. So and I can go back and forth. Once this is done, I can go back to this instance and actually see that the second experiment is running. Okay. So using the power of checkpointing and a shared storage volume, I'm able to go back and forth with data sets, with checkpointing and snapshotting of the data, and the experiments too. All the workloads that I'm running across these multiple instances can share their workloads, all the artifacts. So in the next version of Driverless.ai, which you've probably seen in some of the demos, we have this notion of project workspace. So what we could do is you could have theoretically multiple data scientists working together and sharing projects, sharing experiments, comparing the results, and actually doing this very seamlessly as if they were all working off of the same single drive. And in this case, we are all sharing this 1 terabyte massive cloud drive. It's a fast SSD, and we get the performance benefits out of the box. So that's in a nutshell what we have achieved from an integration perspective. Now, this whole same story can now be applied on-prem as well. So if you were to use it on the ONTAP storage device, which we're working on a joint integration, you can have the same story. And more importantly, you can do this story in a hybrid fashion. So if you have a bunch of servers on-prem, or let's say the DGX machines or ONTAP devices, and let's say you need to bring up more data scientist work, and why not spin EC2 instances and all your data is in your NetApp shared volume that can be accessed by all your users, whether they are on cloud or on-prem, and you can go back and forth as if you're working all of the same instance. So that's what I've achieved, which is pretty impressive, and it's more about convenience. It's getting started, working together, collaborating, using the power checkpointing, snapshotting, and power of NetApp.
So can you just share, quick tidbits on how easy it was for you to spin up the volumes and,
Yeah, so this took us, Nick, who's on my team, there you go. Yeah, shout out to him. He did this whole integration, but it was super easy working with the NetApp team. We were able to spin up a Cloud Volume account, and then once that was done, all you had to do is mount that volume through AWS account so that multiple instances can take it on the same account. Perfect. Once it's done, set up for the first time, when I start a new instance, this shows up, right? So I have this shared volume showing up just like a local file system.
Perfect.
And because of the way we set up driverless to be mounted, having all the temp files mounted over there, I can share experiments, artifacts, the model objects very easily. Awesome. So setting this up was super easy, and more importantly, the experience has been so seamless. So there is hardly any lag. You can literally see the experiments both running in parallel, and you can see how the performance is. So I can see the results for this particular experiment over here as it's running. I can see how that one is doing, and you can go back and forth very easily.
Perfect. And we're going to replicate this on-premise as well. In a on-premise and in a hybrid environment with ONTAP AI, and we are working towards that, and we will shortly announce that.
So you got a minute or so for any questions for folks who might have any. Happy to take some. If not, thank you everyone for attending.
Thank you.
Thanks for the opportunity.